In this video, we're going to be proving several identities involving sine and cosine using the given angle addition formulas. Okay, these are the angle additions, called angle addition because we have two different angles, alpha and beta, and you have the following formula to identify the value of a sine of a sum of two different angles and also the cosine of the sum and differences as well of the two angles. Okay, so the first thing we're gonna take care of is we're gonna prove that sine x is equal to sine pi minus x. All right, how do we prove it? Okay, so to prove this, we need to first, we're just gonna transform the right side into the left side. Okay, so we're gonna do pi minus x. Now, which formula in the angle addition or angle difference are we gonna use? Notice that we're not gonna use the addition, we're gonna use the sine difference of two angles formula, right? Because of the minus sign there. All right, so now notice that alpha and beta are two different angles, and so is the pi and the x, right? So we just copy down the formula correctly and just replace all the correct angles with the respective pi and x that we have here in order to arrive at the correct answer. Right? So how is that going to work? It's we're gonna take the sine of pi because pi corresponds to the alpha, right? So sine of pi multiplied by the cosine of the second angle, cosine of x, right? Because that's the second angle. So cosine of x, okay, minus now cosine of the first angle, that means cosine of pi, right, times the sine of the second angle beta, right? So sine x in this case, because that's the second angle, right? We know sine of pi is equal to 0, so this thing goes to 0, and then minus cosine of pi. What's cosine of pi? It's -1, right? So -1 times sine x. Notice sine x can't be changed because we don't know the x, we just write it down. 0 doesn't count, two negative ones give you positive, +1 times sine x is equal to sine x. Beautiful. So we transform the right side into the left side, right? And by the one of the theorems of algebra tells us that the reflexive property tells us that the right side is equal to the left side, and the left side must equal to the right side as well, right? So we did that successfully. Now the second one we're going to show is going to be to show that sine of negative x is equal to negative sine x. Let's prove that. Okay. All right. So how are we going to show that? So again, we're going to this time start from the left side and just transform it to the right side because that will be the easiest thing to do. Notice that the sine of negative x could be written as the difference. Namely, we know that there's nothing to the left of the negative x, so we assume that it's going to be 0, right? So 0 minus x. Notice that this way we transformed into the difference formula again. So we can use that again, just as we did here, the difference formula for sine of the two different angles. Because 0, notice 0 is also an angle, right? It's the starting point in the unit circle, if you remember that, right? So it is a position actually, right? So now we're going to do sine of the first angle, so that's 0 in this case, times cosine of the second angle, in that case it's x, so cosine x, minus cosine of the first angle, so cosine of 0, and then sine of the second angle, right? So sine x. Let's see what that gives us. We know sine of 0 is 0, this goes away. Cosine of 0 is 1, there's a negative, so -1 times sine x, -1 times sine x is negative sine x, right? So we proved that the left side is indeed equal to the right side. Good. Now the next thing we're going to try, we're going to show that sine of 2x, a double angle formula, is equal to 2 sine x cosine x. Okay, this is going to be a little bit more complicated. So now again, we're going to transform the left side into the right side, all right, this time. So how would you write sine of 2x? Notice again, we can break it up into a sum of two different angles. We can break it up into x plus x, right? Because we know that 2x is the sum of individual x's, right? So we can write it as x plus x. And I know it looks like the same x, but you can treat it as two different angles, alpha and beta. This time we're not going to use the difference, we're going to use the sum, right? Because we're talking about a plus. So we're going to have to use the upper formula, upper left-hand corner. So again, and this is going to be quick because your alpha and beta is the same in this case, so you don't need to worry about that. You can just write sine cosine and cosine sine, right? That's not going to do anything. So you're going to write sine x cosine x plus cosine x sine x, right? Because alpha and beta are the same. This work is really fast. You don't need to, be too careful with what your alpha and beta is, like in different angle examples in the first two that we did. Right? Notice that the product is the same because multiplication is commutative. Cosine x times sine x is the same thing as sine x cosine x, right? It doesn't matter what the order is in a multiplication. These are two like terms. So if you add one sine x cosine x with another sine x cosine x, you get two sine x cosine x, right? So you've successfully proved it using the angle addition formula. Now the next thing I'm going to show, is that let's show sine x is equal to cosine of pi over 2 minus x. Let's try that. Okay, so here we're going to now shift from the sine formulas to the cosine formulas, because we're going to transform the right side into the left side, into the simple left side, all right, using the cosine angle difference formula, right, because of the minus there, right? So how's that going to work out? Here we got to be careful again with the alpha and beta, because alpha and beta are different here. So we're going to start with the cosine of alpha. In this case, it's pi over 2. So cosine of pi over 2 times cosine. Notice that here it's different because in the sine formulas, we had the sine and cosine multiplied. Here's the cosine multiplied and sine multiplied in two different terms, right? So it looks like they're using cosines of two different angles in a single product, right? So that's a little bit different here. And notice the signs matched here. There was the minus and the minus in the given formula, and plus, but here it's the opposite signs. Whenever you add the two angles, you have a minus there in your actual expansion, right? And same thing here, vice versa. You have a negative there, your angle difference gives you an expansion summation, right? You have to add that. Okay, so you got to be careful with that as well. So cosine pi over 2 times cosine x plus, right? Be sure to write a plus, not a minus, plus, and then sine pi over 2 times sine x. Okay, let's see what that gives us. Cosine pi over 2, we know that's equal to 0. So this thing goes away. Sine of pi over 2 is 1. So that means you just get, I'm just going to write 0. Well, I guess I don't need to write 0. I can just write 1 times sine x. All right, and 1 times sine x is equal to sine x. Bingo, we show that, right? So the right side is equal to the left side sine x. Good. Now the next thing we're going to show that cosine of 2 pi minus x, let's show this formula, is equal to cosine x. Okay, let's show this formula. It's going to be very, very, very nice to use. So now it's similar to this formula in which the pi was involved. This time it's a 2 pi involved when we're speaking of cosine to find a second angle with the same cosine value. Right, so again we can use the difference formula for cosine. So we're gonna transform the left side into the right, right? So we're gonna write, how we're gonna write this? We're gonna write it as cosine of 2 pi times cosine of x plus sine of 2 pi, that's the alpha, sine of 2 pi times sine x. All right, let's see what that does. Cosine of 2 pi, as we know, is the same thing as cosine of 0, that's 1. Right, so 1 times cosine of 0. You know, sine of 2 pi is 0, so that goes away. Right, 1 times cosine x, that's it. It's cosine x. Beautiful, right? So we show that the left side is equal to the right side. Now, what else can we prove? Let's prove that cosine of negative x is the same thing as cosine x. Okay? Now, that basically shows that its cosine is an even function. Whenever you have an even the negative of an angle is the same thing as a positive angle. The cosine of these two will be the same. But let's show it using the angle subtraction formula, because we can express it as the 0 minus x, right? 0 minus x, so alpha being the 0. So we're going to show cosine of 0 times cosine x plus sine of 0 times sine of x. And don't forget that the signs are opposite of each other when we're talking about the cosine angle subtraction or angle addition formulas. We have the opposite signs there, unlike the sines. All right, so what are we going to have? Cosine of 0 is 1, so it's just 1 times cosine x. 0, because of the sine of 0, everything in the second term is 0, right? So that 1 times cosine is cosine. Bingo, so we showed that. Okay, cosine of 2x. Let's show that cosine 2x is going to be equal to cosine squared x minus sine squared x. I know it looks more complicated because we're squaring now, but don't worry. It is still doable using the angle subtraction or addition, whatever it is. In this case, we can express cosine 2x as the sum of x and x. Again, just like we did it for this example here, for the double angle formula for sine. Right? We added the x and x. Same thing we can do here. All right, so now what is that going to give us? Again, we're going to use the angle addition formula for cosine. So we're going to have to use a minus between the two products that we get, right? So first cosine, cosine, so cosine x, minus sine x, right? Because the alpha and beta are the same in this case. Sine x, right? So that basically means you get cosine squared x, because squaring, right? Cosine times itself means that it's squared. Minus sine times itself means also squared, right? So sine squared x. Okay, good. Now notice that there's actually something really cool about this. This is not the only value that the cosine 2x is equal to, because we happen to know that we can use the formula for sine square x. We can use the formula 1 minus cosine squared x, right? If we use this formula, we can substitute the sine square x with the 1 minus cosine square x, which also means that we can put that in parentheses, 1 minus cosine. Basically, substituting sine squared with the 1 minus cosine to substitute this part, right? So we're going to get this, and that means cosine will be added to itself because of the double minus. So that means it's going to be 2 cosine squared x, 2 of them, right? So 2 cosine squared x minus 1, right? Because of the negative 1. But you know what? That's not even everything yet. There's one more way, because we know that the cosine squared x, if you rewrite this formula, can be written as 1 minus sine squared x. Okay? So that means the cosine of double angle there can be also written not just 2 different ways, but also 3 different ways. There's a third way, right? Because if you basically use this formula and you substitute the cosine with the 1 minus sine squared x instead, right, this part with that, and then subtract sine squared x by copying that down, you get actually 1 minus twice of the sine squared, because there are 2 of them that you're subtracting. So minus 2 sine squared x, right? So basically, it's fun that actually using the angle addition formula for cosine for the double angle, you get this, but also using the fact that you can use these, right? You can use these formulas. You can actually derive 2 more ways that the cosine of the double angle can be used for. And where did I get this from? I get it from the primary sine squared x plus cosine squared x is equal to 1. So recall that this is a powerful formula from which these 2 are being derived, right? You're just rewriting, solving this for sine squared or solving this for cosine squared. And then using that here to make sure that you can actually write cosine of the double angle as 3 different ways that are very powerful and useful in your real-life application problems. Thank you so much for watching. See you in my other videos.